Scientists are now confirming something that should not be possible under the models we built just a decade ago. Europe's heat waves are breaking records faster than the forecasts meant to predict them, and the gap between what the models said and what actually happened on the ground keeps growing wider with every single event this year. This isn't a story about one hot summer. It's a story about the tools scientists rely on to warn us, falling behind the very thing they were built to measure. Let's start with the numbers, because they tell the story better than any warning ever could. June 2026 became the hottest June ever recorded for Western Europe, with average temperatures sitting more than 3 degrees Celsius above the long-term norm for the month. That alone would be remarkable in any other year. But this wasn't an isolated spike. It came only weeks after a record-shattering heat wave in May, and it was followed almost immediately by yet another heat dome building in early July. 3 separate extreme heat events stacked back-to-back inside a single European summer. Here's where it gets genuinely strange for the scientists tracking this. Seasonal forecasting. Models, the same models that have reliably predicted general summer trends for years, consistently underestimated how intense and how frequent these events would actually become. Climate researchers studying the pattern have pointed out that the observed temperature records aren't just edging past the old highs. In several countries, they're blowing past them by margins that fall outside what the statistical models considered even remotely likely going into the season. Take Hungary as one clear example. Forecasters projected a warm June, as they typically do for that region and that time of year. What actually happened was a new all-time June record near the capital, with temperatures climbing to just over 40 degrees Celsius, a mark that shattered the previous benchmark rather than simply nudging past it. Austria told a similar story, setting a brand new June temperature record. In Vienna itself, while the National Weather Service there issued a red alert for the capital, a warning level rarely triggered this early in the season. The United Kingdom offers maybe the clearest evidence of models struggling to keep pace with reality. The Met Office issued red warnings for extreme heat on consecutive days, something that had never happened before in the entire history of the country's current warning system. 3 straight days of the highest possible heat alert level is not something any seasonal outlook flagged as a realistic scenario going into the summer. And yet, it happened, in real time, in front of everyone watching. If you're finding this breakdown useful, go ahead and hit that like button. It genuinely helps this kind of climate coverage reach more people who need to understand what's actually happening. So why are the models missing this? The honest answer scientists are giving involves several compounding factors, and none of them are simple. The first, and probably the most important, involves the ocean sitting right off Europe's own coastline. Sea surface temperatures across the Mediterranean and along the Atlantic coast reached the highest levels ever recorded for the month, and that matters enormously for how heat behaves once it settles over land. A warmer ocean means more moisture and more stored energy feeding directly into the atmosphere above it, and that stored ocean heat doesn't show up cleanly in models that were originally calibrated using decades of cooler baseline data. Researchers at the European Center for Medium-Range Weather Forecasts have specifically pointed to this ocean heat accumulation as a core driver behind the disconnect. One senior climate lead there described it plainly, saying the records reflect a climate system that keeps accumulating heat rather than releasing it, and resetting the way older models assumed it eventually would. In other words, the ocean isn't behaving like it used to, and the models built around old ocean behavior are consistently coming up short. The second major factor is the specific atmospheric pattern locking this heat directly over the continent. Meteorologists call it an omega block, named for the shape it traces across a weather map. It forms when a ridge of high pressure gets pinned in place between 2 low-pressure systems on either side, and once that shape locks in, it can hold steady for days or even weeks rather than passing through the way ordinary summer weather typically does. Research published through the Proceedings of the National Academy of Sciences found that this exact category of blocking pattern has very nearly tripled in frequency compared to the record before large-scale industrial warming began. That statistic alone should reframe how anyone thinks about seasonal forecasting going forward. A pattern tripling in frequency within a matter of decades isn't the kind of shift older statistical models were ever designed to capture, because those models were built on historical baselines that simply didn't include this level of atmospheric instability. When the underlying physics of the system changes this quickly, forecasts trained on the old normal start, missing the new normal almost by definition. There's also a third piece to this puzzle that deserves real attention because it explains why each individual heat wave keeps feeling more dangerous than the temperature numbers alone would suggest. Overnight temperatures across the hardest hit regions have consistently failed to drop the way they normally would after sunset. One weather station in eastern Germany recorded an overnight low that barely dipped below 29 degrees Celsius, a reading that would have counted as a hot daytime. Temperature in an ordinary summer just a few decades ago. That failure to cool overnight matters enormously for public health because the human body relies on that nighttime drop to recover before the next day's heat begins building all over again. Scientists studying this pattern have specifically linked the loss of overnight cooling to the unusually warm Mediterranean sitting just off the coast, describing it as a kind of fingerprint the warm sea leaves on the land nearby. And here's the part that ties directly back to the forecasting gap. Older heat models were built primarily around peak temperatures, since that's traditionally been the most dangerous and most measurable part of any heat wave. But if the real driver of harm is shifted toward relentless overnight heat that never fully breaks, then models still anchored to daytime peaks are going to keep underselling exactly how dangerous these events actually are. Put these three factors together: the record warm ocean feeding extra energy into the system, the blocking pattern locking heat in place far longer than usual, and the disappearance of overnight relief, and you start to see why the gap between prediction and reality keeps widening. Each factor alone would stress an older model. Stacked together, they produce outcomes falling well outside what forecasting built on 20th century data was ever designed to anticipate. This isn't just an academic concern, because these forecasting gaps carry real, tangible consequences on the ground. Emergency planners, hospitals, and power grid operators all rely on seasonal forecasts to prepare resources ahead of time, from staffing cooling centers to positioning medical crews in the neighborhoods most likely to need them. When a model underestimates how extreme a coming heat wave will be, that gap translates directly into risk for the people those systems are meant to protect, particularly elderly residents and anyone without reliable air conditioning. France offers a useful comparison because it shows what happens when institutional preparation partially offsets a forecasting shortfall. After a catastrophic heat wave and 2,000 people across the continent, France spent 2 decades building a formal national heat response system, including cooling centers, welfare checks for elderly residents, and automatic alerts once temperatures cross set thresholds. That system doesn't prevent every death, and this year's toll makes that painfully clear. But researchers have found it holds mortality meaningfully below what less prepared regions face at comparable peak temperatures. Regions without that same institutional memory, particularly parts of Central and Southeastern Europe, with lower rates of home air conditioning, have shown sharper spikes in heat-related hospital admissions with each repetition of this pattern. That gap has less to do with how hot any single heat wave becomes, and more to do with how much planning existed before it arrived for the 3rd or 4th time. Planning that depends on forecasts, giving officials enough accurate warning to act. So where does this leave the science going forward? Researchers aren't suggesting the models are broken beyond repair, and they're careful about that distinction. What they're saying instead is that the climate system has entered a phase where conditions are shifting faster than traditional statistical forecasting, built on historical baselines, can fully keep pace with in real time. Meteorologists are increasingly leaning on newer approaches, including machine learning-based forecasting tools that can update and adapt more quickly as fresh atmospheric and ocean data comes climatology, the way older seasonal models have for decades. If that shift continues, and there's growing reason to think it will, the gap between prediction and reality may narrow again over the next several years as forecasting systems adapt to a climate that keeps moving the goalposts. For right now, heading into the back half of this summer, multiple, independent seasonal outlooks are already tilting firmly toward continued above normal heat, with forecasters describing this less as separate hot spells and more as a single pattern reasserting itself onto the same stretch of the planet every few weeks. What this all boils down to is genuinely simple, even if the science behind it is anything but. The old assumption that a seasonal forecast issued in spring would reasonably capture what actually happens by summer's end no longer holds the way it used to across large parts of Europe. The ocean is holding more heat than the models expected. The atmosphere is locking into blocking patterns far more often than the historical record predicted. And the danger itself has partly shifted toward overnight hours that older forecasting frameworks were never built to weight heavily enough. Every one of those threads is measurable, documented, and actively being studied right now by researchers racing to catch up with a climate system that keeps outrunning the very tools designed to describe it. It also helps to remember how recently this kind of gap would have seemed unthinkable to the people building these forecasting systems. Seasonal models used to be judge D successful if they captured the broad shape of a summer, warmer or cooler than average larks, without needing to predict individual record-breaking events with real precision. That standard made sense in a climate shifting gradually from one decade to the next. It makes far less sense in a climate where the underlying baseline itself is moving this quickly, since a model can get the broad trend right, while still badly underselling the extremes sitting inside it. This is part of why researchers keep emphasizing the difference between weather and what they now call a climate regime. A single hot week passing through is weather, the kind of thing forecasters have always been reasonably good at predicting a few days out. A pattern reasserting itself onto the same geography every few weeks, driven by measurable shifts in ocean heat and blocking frequency, is closer to a new regime altogether, and regimes like that don't behave the way the historical training data assumed they would. For anyone living through this directly, the practical takeaway isn't really about the models at all, even though the models are the part making headlines. It's about treating heat safety as a season-long habit rather than something you only think about the week a red warning gets issued. Check on elderly neighbors regularly, stay hydrated even on quieter days, and take official warnings seriously the moment they come out. Because if forecasts are already running behind reality, waiting for the worst case warning before acting may mean waiting too long. If you want to keep up with exactly how this pattern develops through the rest of the season, subscribe so you don't miss the next update the moment new data comes in. And if this breakdown helped you actually understand why this summer keeps outrunning the forecasts, leave a like on your way out. It genuinely helps this kind of coverage reach the people who need to see it, because based on everything the researchers are currently saying, this almost certainly will not be the last time this year that the reality on the ground outpaces what the forecast said to expect.